All right. Hello, everyone. Welcome to Homework 3 video solutions. Um, so let's start off with problem one. For the shift lever shown, determine the magnitude and the direction of the smallest force P that has a 210 pound-inch clockwise moment about B. So here, whenever I start off a problem, I start off by writing out my given information as well as the equations that I'll be using and what I'm determining. So in the problem statement, we're given that m of b is equal to 200 pound inches in the clockwise direction. And we also know that the moment for a 2D problem like this is equal to the perpendicular distance times the force, denoted with a little upside down t. Um, so we want to know what the minimum force is for P. And the way we can do that is by getting its perpendicular distance, because any force that isn't perpendicular will be greater. So as you can see, I've denoted a theta angle here. And for this value to be at its minimum, we want to set alpha equal to theta. And so to find that value, we can see that a triangle forms here. And so we can use, we know that tangent of theta is equal to opposite over adjacent. And then we know that our opposite is 8 in this case from theta, measuring from theta. The opposite is 8. And our adjacent is 22. So we have 8 over 22. And then we're also going to take the inverse of tangent so that we get our theta value. Sorry. We're here. So I'm going to move this over. Oh, it's not working. Just erase. So we'll get our inverse of tangent, and then we have 8 over 22. And that, when you plug into your calculator, is going to be equal to 19.98 degrees, or whatever value you're given for the problem. And now that we have that angle, we can use that to find the minimum P. So our distance D that is perpendicular is going to be the hypotenuse of this triangle that we've created. And if you remember from Pythagorean theorem, a squared plus b squared is equal to c squared. So if I plug in for these values, I'll get that c, or in this case is our d perpendicular value, is going to be equal to the square root of 8 inches squared plus 22 inches squared, which is equal to 23.41 inches. And then after that, so this value right here is our D perpendicular. And now we can plug that into this equation right here to get our P. And in this case, our P is this F value right here in the equation. So we'll rearrange the equation, and we can find that P is equal to M about B over D perpendicular. That's equal to 210 pound inches over 23.41 inches. You can see that the inches cancel out, and therefore our answer is in pounds, and we're left with 8.97 pounds. So this is the minimum p-value that it takes to produce a moment of 210 pound-inches, and the direction is this value right here. So that's problem number one. Let's move on to problem number two.